We all know that space is vast. It's enormous. There are still many things that we don't know about, but slowly we are discovering things, and every day we get close to discovering something new. Some things are really shocking. What would be your reaction if I tell you that there is a moon that is almost 3 times the size of the moon? Well, let's see how much truth in this statement. Welcome to another video of Cosmos Observer, the only destination for your space curiosities. Astronomers think they've found an exomoon, a moon that exists outside our own solar system, based on data from NASA's Kepler spacecraft that observes planets outside our solar system. There is still no confirmation of the first ever sighting of an exomoon in 2018, so there is no confirmation yet. On the other hand, there are 4,905 confirmed exoplanets in 3,629 planetary systems, with thousands more to be discovered. The prefix ex or exo is from Greek, meaning outside, outer, or external. Spotting a moon or even planet hundreds to thousands of light years away is anything but straightforward. Moons and planets can only be observed indirectly as they pass in front of their host stars, causing the star's light to dim intermittently. Catching one of these fleeting transmit signals with a telescope is tricky, and so is interpreting the light curve data. Exomoons are even more challenging to detect than exoplanets because they're smaller and block less light. While we have gained some exciting insights into the solar system's moons, identifying and studying their extrasolar counterparts is much more complex. In fact, experts have only so far managed to track down 2 natural satellites outside our planetary system. A look at recent research history proves that the exploration of the universe is becoming more and more concrete. The first extrasolar planets discovered outside our solar system and gravitationally bound to another host star were added to stellar maps in the mid-1990s. The galactic search for clues yielded numerous rewards. 904 exoplanets in 3,628 different systems are known, with a large portion of these strange celestial bodies identified indirectly through the transmit method. When a planet passes by its parent star, it always obscures a part of the host star for the observer. Its brightness is subject to apparent variations to exclude that another event triggered the registered brightness change. A minimum of 3 transits at the same time interval must be documented with the corresponding brightness. The stars not only indicate the actual existence of exoplanets, but some characteristics of the accompanying celestial body's orbits. The probability of observing a planetary transit at a randomly selected star is reported to be less than 1% when the planetary radius and orbital inclination are taken into account. So what doesn't appear to be particularly promising at first glance has already helped researchers reach numerous milestones. More than 3,000 exoplanets have been discovered using the transit method, accounting for more than 80% of all known extrasolar planets. Because almost every planet in the solar system has at least one natural satellite, it's reasonable to assume that this pattern holds true for planets orbiting stars other than the Sun. The unfortunate reality is that satellites are frequently too small to be detected. Let's take a closer look at the corresponding celestial bodies and their known characteristics. The first exomoon candidate is about 8,000 light-years away from Earth in the Swan constellation. The exoplanet Kepler 1625b moves in its orbit discovered based on the transit method by the Kepler Space Telescope in 2016. The distant celestial body has a diameter that exceeds that of our blue home planet by at least 6 times. Specifically, the gas giant Kepler 1625b could be comparable in size to Jupiter while possessing 10. It must orbit 3 times its mass to orbit its ancestral host star, a so-called subgiant with a mass similar to that of the Sun. The exoplanet estimates about 287 days for the transit of the celestial body, which experts have calculated. So far, they have been able to document the unusual shapes of light curves. The first known exomoon in the history of science is even more exciting because if the satellite exists, it could be located in the habitable zone of its system with its planet. Remember, the habitable zone is defined as the distance range in which a celestial body must be located in relation to its host star in order for water to exist there in a permanently liquid form as a basic prerequisite for life. The gratifying finding was that the anomalies in the light curve of Kepler were confirmed again. A second, much fainter dimming of the central star followed, indicating that the planet was accompanied by a smaller moon. Another clue suggesting the existence of this exomoon is the time of the transit. The gas giant began transit scarcely 80 minutes earlier than the researchers had predicted due to its orbit. In fact, such deviations may be due to the gravity of a satellite. In simple terms, the satellite causes its planet to sway slightly so that it is sometimes slightly ahead and sometimes slightly behind its expected position. Although the actual presence of the first discovered exomoon in history has not yet been confirmed, Experts believe it's most likely that the observed anomalies are due to the influence of the satellite. Accordingly, Kepler 1625b could have a satellite the size of Neptune that orbits it in orbit, inclined at 45 degrees. However, according to the researchers' assumptions, the moon in question would not be solid. Still, a predominantly gaseous astronomical body, so even if the moon is in the habitable zone of its system, it's considered unlikely to harbor Earth-like life. Magnificent supermoons are no less captivating than the observation just presented, which was the news that made the headlines. A few weeks ago, scientists succeeded in tracking down another exomoon candidate, this time the exoplanet Kepler 1708b, which is 5,500 light-years away and the size of Jupiter. In this case, too, it was conspicuous features in the light curve that suggested the presence of a natural satellite in terms of its dimensions. The celestial body astonished the experts. It, like its predecessor, could be a particularly massive supermoon nearly 3 times the size of our planet. This exciting discovery began when a team of researchers at Columbia University were working on combing through the previously collected transit data of 70 exoplanets to look for evidence of extrasolar moons. The planets in question were cold gas giants, separated from their parent stars by fairly large distances. Therefore, such gas planets of the size of Jupiter hold a particularly large potential for knowledge in the formation of satellites in this case. Because gas planets are born in particularly densely populated regions of the primordial cloud, there is always enough material left to form the satellites. Since gas planets are also known for their large gravity, they are true masters at capturing the corresponding one of the later moons. After 11 of the 70 light curves studied had been shortlisted, they finally emerged as a particularly promising candidate. To all appearances, both the companion of Kepler 1625b and the satellite of Kepler 1708b seem to embody massive supermoons the size of full-grown planets. However, before the existence of these exciting celestial bodies can be confirmed, we have to be patient. So far, no telescope on our planet has been able to take direct images of satellites. Experts are still heatedly debating whether such supermoons can actually exist and how they might form. It's possible that the exciting discovery that was recorded last year with the radio telescopes of the ALMA Observatory could shed some light on the matter. At that time, a circumcised disk around a fledgling gas giant outside the solar system was identified for the first time. The rotating cloud of gas and dust contains enough material for the formation of 3 Earth-sized satellites. As a result, scientists now believe that both Jupiter's moon Europa and Saturn's satellite Enceladus have massive oceans beneath their icy surfaces. So while we've learned a lot about our solar system's moons, finding and studying their extrasolar counterparts is much more complicated. In fact, scientists have only seen 2 natural satellites outside our solar system so far. The radio telescopes at ALMA Observatory shed some light on the subject last year, the findings that the researchers will collect and publish in this regard in the future. It is a stunning discovery. Discoveries like this make us realize how tiny we are in this vast universe. I hope that we will hear more about this moon soon.